Alrighty. So for today we have Tyler, Caesar, Angel, and Ella. Hi. Okay. Trying to make sure that I do remember all my students' names. All four of them. Yeah. King, great. All right. Cool. It's now 12:30. Awesome. Hello, everybody. Welcome back. Welcome back to another wonderful lesson of Intro to Programming in Python. Today we're going to be covering something called while loops. Okay. So just like yesterday when we were talking about for loops, right? We're going to go through a list, right? We're going to look at something and go through the whole entire thing. And we have to rerun code over and over and over again within a loop. There's this other loop called while loop. Okay? We're going to get really, really familiar with the while loop today. So let's continue on. Oh yeah, a little quick important life lesson. So a little bit of slope makes up for a lot of y-intercepts. So basically what this is trying to say is that if you try to do something good, just a little bit better every single day, at one point you're going to be doing even better than if you just kept on with a different slope without doing something good additional every day. Okay? What I'm trying to say is when you are working hard towards something, in this case learning about computer science, right? Sometimes it seems like, you know, I gotta work hard, right? But if you work just a little bit harder every day, by the time that we get to the end of the class, y'all are gonna be really great, really capable programmers, okay? So, I really hope that y'all check out the reference too. Check out the reference here in the link that we have in the bottom of the slides. Before we get started in terms of the content, today is the last day to submit PA1 using your slip days, okay? So as we said before, PAs, you get 2 slip days to use for free, no questions asked, within a single PA. And today is that second day. Today is that second day to use a slip day. So if you have not submitted your programming assignment, today is the final day to do so. And make sure to actually click the submit button. Don't just be testing your code, right? I mean, always test your code. But when it's time to submit your assignment, you have to click the submit button, okay? PA3 will be released tomorrow, okay? So I know that we have PA2 out right now. We're also going to be having PA3 be released out tomorrow. So, you know, there's a lot going on, but we want to make sure that y'all get all the help that y'all need. So again, please, please, please go to office hours, go to labs, go to come to lecture, go to discussions. If you can't make one of these, make sure to go to the media gallery to look at the videos for these help hours, okay? And then just as a reminder, today's discussion over at Pepper Canyon Hall, 120. And something that I wanted to reiterate, well actually iterate, I don't think I ever said this to the class just yet, but discussion goes over questions that are very similar to the exam, okay? Not just the midterm exam, the final exam as well, all right? So the type of work that you'll be doing in the discussion is going to be going over some questions that are going to look very similar to what we're going to have in the exam. We have our midterm exam next week, actually a week from today, I think, yeah? So a week from today, you will be having a midterm exam. So I highly recommend going to discussion, where you're going to be going over questions that are very similar to that exam. So please, 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 go to discussion. We have discussion today. Our wonderful TA, Chao Hui, who's sitting in the back, goes over all the discussions. So make sure to reach out to him as well. All right. So yesterday, we covered for loops and range, right? We very quickly talked about range, right? And we're going to be doing a really quick example too about how we can use for loops, right? Redoing code over and over and over again with the range function, right? So we're going to try and print out this wonderful little triangle. Okay? We want to print out this triangle, and we want to make sure that we can build this triangle based off almost any base that we want, right? We want to make it, if we want to make it 5, 4, 3, 2, 1, great, we can do it like that. But if we want to make it larger or smaller, we can do so by creating a function, right? We can create a function. And why don't we go ahead and get started with that? So, I mean the answer's right there, but let's write it all out together. Okay, here we go. So, we're going to want to create basically a function that's going to print out a triangle. And the triangle has to look like this. There has to be an asterisk. Then the next line has to have 2 asterisks. And the next line has to have 3 asterisks. Then the next line has to have how many? 4 asterisks. Then the next one will have 5. Then the next one will have exactly, yes. And we'll go over and over and over again. Okay? And it all depends on what the user wants. How large do we want this triangle to be? And we have to ask the user. Okay? So, we can start off with a function, right? DEF. That's how we start off our functions. All lowercase. And then we're going to call it print triangle. Okay? Because that's all we want to do. We want to print the triangle. And depending on how large we want the triangle to be, we have to look at the base of the triangle, right? How large is the bottom of the triangle? Is it 5 asterisks long, 6, 7, 10, a billion, right? So we're just going to call that base. This is a number that we want to look at. Okay? This is the number that's going to depend on our system. Right? So, now we go inside the function. Remember, when you go inside the function, you have to use this indent. No indent, you get errors. Okay? Now, we have a number about how big we want it to be. But how can we start off with a single asterisk and go all the way up to this number? Mm-hmm. Okay. Yes?
Like a for loop?
A for loop. Yeah, we can absolutely use a for loop. So let's just make a for loop really quick right now. For, what do we want to iterate through, right? For loops that we use, we're usually using them so we can go through a list of something. How much do we want to go through right now? Where do we want to go through? I don't know yet. But I do know one thing. I know that one thing I want to do is I want to keep on printing stuff out, right, on new lines. The 1, 2, 3, 4, 5, 10 asterisks. And I want to stop at a certain amount of asterisks. I want to stop at this base right here. Okay? So, what I could do is probably use that range function that we used yesterday. Okay? So for, let's just call it num for now, because we know that the range function will give you like a list of numbers. For num in, how do we use the range function again?
Range, and there's a start, a stop, and a step.
A start, a stop, and a step, right? Start, stop, and step. Okay. So where do we want to start off? So if we want to start printing out an asterisk, we know that on the first one, we want to print out 1 asterisk. On the second one, we have to want to print out 2 asterisks. The third one, 3 asterisks, etc., etc. So where do we want to start off? Let's start off at 1. Okay. So we can make our start number 1 or 0. Are we indexing at 0? Or are we indexing at 1? What do we want to start off with? The start. If we put 0, are we starting at 0 or are we starting at 1? We're starting at 0. So if we want to start off at 1, let's use 1. Then we want to stop at a certain point, right? So if we want the bottom one to have a total of 5 asterisks, and we start off at 1 asterisk, Up until when do we want to stop?
6.
6? Okay. Why 6?
Because it's exclusive. It doesn't include the last one.
It doesn't include the last one, right? Then we got the step, right? How many times do you want to skip any numbers, or do you want to stay with one number, like stepping by ones? Step by one. Okay. All right. So now what we can do is we can print stuff out, right? We can print out an asterisk. Let's see what happens when we do this. Let's just print the triangle. And let's see, we want 5. Let's run that. Okay, great. We got a total of 1, 2, 3, 4, 5 lines where we're doing. That's great. We wanted a 5, right? So, right now we're only printing one asterisk. How can we print multiple asterisks depending on where we are in the for loop? So on the first time in the for loop, we want to print out 1. Then on the second one, we want to print out 2. And on the third one, we want to print out 3 different asterisks. How can we do that?
You could use the double asterisk and
Double asterisk like this?
outside of it.
Oh, sorry, like this?
No, in the same line.
Okay, same line.
Inside the yeah, there.
I do like this?
2.
2.
Or second asterisk.
Oh, sorry. Oh, the second asterisk, like 2 asterisks like this?
Yeah.
Okay.
Num.
Okay. What is this doing here?
It reprints it according to the variable num.
It prints it according to the variable num.
Or
So let's assume that num is 2, for example. What's going to happen?
it'll print out 2 asterisks.
2 asterisks. Okay, let's try that out. Let's see if it works out. Let's run it. Oh, unsupported at boyfriend. Oh, I see what's going on here. We put 2 asterisks. 2 asterisks, remember 2 asterisks is exponents, right? So exponents means that you're going to multiply one thing a certain amount of times, right? So it's like you're multiplying that same thing over and over and over again. Can you multiply integers with integers? Yes. Can you multiply floats with floats? Yes. But can you multiply strings with strings? What's Ismaili times Ismaili? We can't really do that, right? So instead of doing the exponent, what we can do though is a multiplication, right? Because we can multiply, what's Ismaili times 2? That's 2 Ismailis. What's Ismaili times 5? That's 5 Ismailis, right? So let's try that out. Let's run it. Oh, great. Okay. That's working. We have our 5 asterisks. Let's do like a smaller one. Let's just do 3. Let's run that. Oof. Now I have 5 again still. What's going on here?
The range is set. No, so no matter what input you put, it'll always be the same.
Aha. No matter what you give as a base, right? Here I put 3. We're never using base inside the function. We are hard coding. That's a term that we use in computer science. Hard coding. Hard coding is when you have this variable that you could use, but you're actually not using it at all. And you're putting a fixed number in there. And this fixed number, we put a fixed number of 6. So instead of 6, we could put the base, right? So we want to start off at number 1 and go all the way until we get to the number base, right? So let's try that out. Let's run it. Oof. So we did fix it a little bit. Now we're not getting 5, but now we're only getting 2 things. We need that third line, right? Our base has to be 3 asterisks long. Yes?
Oh, it's only because base is exclusive?
Base is exclusive right now, right? When we're looking at this range, base is exclusive. So if we want to just include the number for base, what do we have to do?
Plus 1.
Plus 1. Plus 1. Let's run that. Ta-da! We got our 3. We got to test it. Let's just make sure that it's still working. Let's do 5 again. 5 looks good. Let's do 10. Oof. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We did it. Okay? So what we're doing here is that we're using a for loop. Usually we would use the for loop right when we first learned about for loops. We used it a lot on lists, right? List of like names, a wait list, right? A list of country names. This right here, range, is going to give you back like a sort of list, right? A sort of list where you're giving it the parameters of what this list is supposed to look like. I want to start up at 1. I want to go all the way up to the number base plus 1, but not reach that number just yet. And I want to go up by 1 in each element. Okay? Does that make sense? Yes, no, yes, no? Any questions so far? No? All right, great. So, let's continue on. All right. Now we have a quick exercise. What will be printed? We're going to use for loops. We're going to use the range function. Okay, range. And now we have this list of, let's just read the code really quick. So we have this function called find center, and we're going to put in a center, something called center, and something called centers. Okay? We don't need to look at the function just yet because we're not calling it, right? Let's just read it like we're the Python program. So we finished the function. Centers is this list of strings. Apimeda, BRC, CCC, ITRC, and raza. Okay? These are actually all centers here at UCSD that you can find, resource centers, such as the Asian Pacific Islander Middle Eastern Desi American group, the Black Resource Center, the Cross Cultural Center, the Intertribal Resource Center, and the UCSD Raza Resource Center. Right? So we have this list of centers. And now we're going to do find center. We're going to try and find something. Right? We're going to try to find a center. And we're putting in the string raza, and we're putting in our list of centers. Okay? Now let's look at the function. For, we have a for loop now. IDX, what's IDX going to be?
Index.
An index, okay? Index, IDX, so this is like some variable, we're just giving it the variable IDX, right? And IDX is going to be the index in, we have this range function again. So what's this range function going to give us right now? We're looking at the length of centers, right? We know centers, we saw centers before. And we know what len does. Len gives us the length of a list. What's the length of this list so far? 1, 2, 3, 4, 5. It's going to give us 5, right? So this is going to say range of 5. What numbers are we going to see when we just put range 5?
0, 1, 2, 3, 4.
0, 1, 2, 3, 4, right? We start off at 0. If there's no other start parameter that's given or argument. And then we go all the way up until this stop. This stop of 5, exclusive. So now we're checking to see if the centers at a certain position, in this case IDX, is equal to center, something that we put in, raza. Okay? So what's going to get printed out? Sorry, what will be printed from this system? Is it going to be raza, true, false, or error? Oh, geez. I don't think it's going to be any of that. Looks like someone's got to update their slides. Sorry about that, y'all. Let's actually, great learning opportunity. Let's look at this. Okay? We have this whole, oh, dang it. Sorry about that. We have this system, right? This whole program. Let's run it. Okay. So we have find centers. We're looking for a certain center. And right now this return, if we find our center, right? So we're going to look at our list. We're going to look at the position of that list at a certain number, IDX, and this could be 0, 1, 2, 3, or 4. And we're going to check to see if center is there. Center is something that we're giving it, raza. Right? Actually, this is also a perfect opportunity to use our Python tutor. Right? So we can actually see exactly what's going on. Python tutor. Let's put that there. Let's visualize it. So we read our function. We know that it's find center. We have a list of centers. And we're going to go into find center, where we're giving it a string called raza, and we're also giving it a list of centers. Okay? So now we're going to use our for loop. In our for loop, IDX is going to go through the range of the length of centers 0, 1, 2, 3, and 4. Right? And we start off at index at 0. Okay? Then we use this number 0 to check the position of centers. So what is centers at position 0? What is that? What are we going to see? Apimeda, yes. Apimeda, this right here, this string right here, APIMEDA. Is Apimeda equal to the string raza? No. Right? So, we go next. And then we're done. Oops. We print out false. We print out -1, sorry. We print out -1. What happened here? We followed the code exactly as it was written. Okay? We followed it exactly as it was written. Because we followed it exactly as it was written, this function, right? This function says, okay, we're going to use a for loop. That's great. But we have this return inside the for loop. Returns for functions are very strict. It doesn't matter where you are in the whole system. It doesn't matter if you're in a for loop. It doesn't matter if you're in a conditional. It doesn't matter at all. As soon as you hit return, you're getting out of there. You're getting out of that function immediately. Okay? So as soon as we saw this, if Apimeda is equal to the center, if it's true, we go in here and return the index. It wasn't, so else we return -1. But since we went into this else statement immediately, we immediately return the number -1, and then we leave the function. So something's wrong. This function is supposed to find the center. Does it exist inside of this list? In this case, raza does exist within the list. It's right here. Right? And we want to print out the position, the index of that of where it's found in the list. Okay? So where is it found in the list? What index number is this? 4. 0, 1, 2, 3, 4. So the system should return 4, but it's not, because we have this return -1, right? So what we can do is, instead of immediately returning -1, if we don't find it, we can still return -1 only if we didn't find the position of the list, right? If we didn't find it, then we could return the number -1 and say, hey, I looked for the index and it's not there. Okay, we can try and do that. So instead of immediately returning, as soon as it checks that first instance of the list, that first element, that first item, it checks it, it's not there, and immediately returns -1. What can we do instead? Do we want to, oh sorry, you were going to say something?
Oh, like delete like the else,
Delete the else. Let's do that.
and then press backspace on the return a few times, or twice.
Twice. Why twice?
Because then it's out of the for loop, so once the for loop completes and it doesn't find the center, it'll return -1.
Precisely. So basically, we're only ever going to read this line of return -1 if we go through the entire for loop and we never go inside this if statement, right? Because if we hit this if statement, return index, we'll never read this last line. Because as soon as you hit return, what happens on functions?
It goes.
Immediately leave. Immediately, right? And you won't read the rest of that function because you're returning, immediately returning, grabbing that information, giving it back, right? So if we never make it inside of this conditional, then that means that we never found the center that we were looking for. That means we finish this for loop, and we finally read this last one, return negative 1. And we're saying, hey, we tried, we really did our best, but we couldn't find it. So we're returning negative 1. Let's run this now. Now we are getting 4, right? Now we are getting 4 because as soon as it gets indexed at 0, indexed at 1, indexed at 2, indexed at 3, indexed at 4, when we're at index at 4, we check centers. We check the position at 4, 0, 1, 2, 3, 4. It gives us a string, raza. It compares it against the center that we're looking for, raza. They're the same. We found it. This condition is true, which means we go inside the conditional statement, and we immediately return that number, the IDX number, which is 4. Does that make sense? Yes? All right. Oh, I got to update the slide. So it turns out this one, we made the slide to be on purpose to have this else, right? Return negative 1, so we could show exactly what's going to happen when we have this return inside of a for loop. But this I do have to update. Sorry about that, y'all. Instead of true and false, it should be like 4 and negative 1 or error. Okay? Let's do that now. 4, negative 1 or error. Cool. All right. Let's continue on. Now we have this new function, student in waitlist. Right? Waitlists are something that many of us have been in, right? A waitlist to get into a class. And you get into the class depending on where you are on that waitlist. If you're waitlist number 1, that means you're the very next person. If someone drops, you're the first one to go inside, right? Into that class. So the position of where you are in that waitlist really matters. Right? So right now we have a waitlist. Audrey's the first one on the waitlist. Congrats, Audrey. As soon as someone drops the class, Audrey will be the first one to go into that classroom. 2 people, then me. I'll go into the classroom. Then Inti, then Jacqueline, then Noch, right? So we need to find out the position of where someone is in the waitlist. So we have this little function. Is this function doing precisely what we want? Let's read it. Okay. If a student's name is in the list, return the position of the student in the list. So wherever they are, right? If a student is not in the list, then we return negative 1. Cool. Great. Is this function doing precisely that? Yes or no? I'll give you all a second to just read it through. What will be printed when we do this line right here? Print, position in waitlist, waitlist, Audrey.
1.
1. Should it be 0 or should it be 1?
It's plus 1, right?
Ah, yes. It's return index plus 1. Audrey is currently in the index position 0. Right? But right now, for the purposes of this function, we want to return whatever their index is plus 1. Because we want to return their position, right? Where anyone of us could read that position. Or someone that doesn't study computer science can understand what that position means. If you ask someone that's never taken a CS class before, and they're saying, what position is Audrey in? Or you're like, oh, it's the 0th position. They're like, what are you talking about, right? 0th position? That doesn't make sense. So we're making this function so that anyone can read it. What position is Audrey in? She's in the first position, right? She's the first one in the wait list. So 0 plus 1. Does that make sense? Okay, great. Cool. What about Sitlali? What do we put in Sitlali? what will be returned?
-1.
-1. And why is that?
Because they're not in the wait list.
They are not on the wait list, right? So if we go through the whole entire for loop of that range, we never find Citlali, so then we have to return -1. What about Inti? What gets returned? When we put in Inti. Sorry? 3. Yes, sorry. I couldn't name the plane. But yes, 3. 0, 1, 2. Inti is at position 2 of the wait list, but then we return +1, 3. Great. Cool. Oh, this is another one of those trick questions. But we just went through one of these, right? Where what's happening here is we have this else statement that returns -1, right? So what's going to happen here? The very first person that we check, Audrey, right? We check at index 0. Audrey is not the same as who we're checking for, Jacqueline. Because of that, we don't go into this if statement, but there's an else statement, so we will go there, and we immediately return -1. And what happens when we return inside of a function? You leave the function immediately, right? You do not stay for a second longer, right? So that's why this return is very important in functions. It's very important about where it is. You have to use it exactly where you want to use it. If you accidentally use it too soon, then you'll never see the rest of that range, right? Because you immediately left. That makes sense? Awesome. All right, today we're going to be covering while loops. So all this for loop stuff, right? We're going for through a list of centers, through a range, right? And the range being a list of numbers. Now we have this new thing called while loops. And we're going to cover the basics real quick. A while loop is very similar to a for loop in that you're going to have like a block of code that you're going to want to read over and over. Except now, with while loops will continue to read stuff until a condition is met. Or sorry, while a condition is being met. So while something is true, I'm going to keep on reading this, right? Non-stop. Until whatever this is becomes false. Then I'll leave. Let's look at it really quickly, what that looks like. So, let's do a really quick game. I'm thinking of a number between 1 and 10. What do you think it is?
5.
No. What do you think it is? No.
1.
1, no.
7.
7. It was 7. Congratulations, right? That took us 1, 2, 3, 4 tries, right? Let me think of a different one. Okay. What do you guess?
3.
No.
8.
No.
7.
No.
9.
No.
8.
No.
1.
No.
4.
No.
2.
2. That took us 1, 2, 3, 4, 5, 6, 7, 8 tries this time, right? So what we did here is that I didn't stop asking all of you about what the number I was thinking of until we found what it was. AKA, if we had a while loop, I'm going to say while you have not guessed my number, I'm going to keep on doing something. And what was I doing? I was asking, right? What's my number? What's my number? What's my number? And I didn't stop. Until we found the number. And as soon as we found the number, we can leave the while loop. Okay? Oh, when it's done, celebrate. Okay, so let's make this really quick guessing game. Okay? Actually, no. We shouldn't do that guessing game just yet. We'll do that guessing game very soon. Okay? We'll implement this game ourselves. But we can do a different use of the while loop, right? So we have to make sure that whatever is in the while needs to be true to continue doing something. So let's assume that you are all trying to qualify for the Olympics, right? The sport. And we're looking for the high jump. Okay? Cuban high jumper Javier Sotomayor. They have a world record of 2.45 meters. That's 8 feet and a 1/4 inch high for men's high jump. And this high score has not been beaten since 1993. Longest standing record in the history of men's high jump. And all of us are going to try and compete with Javier Sotomayor right now. We're going outside for a field trip. No, so what we want to do is we want to check to see whether we can all compete in the Olympics. But in order to get into the Olympics, you can't just sign up, right? Ella can't just go up and say, hey, I want to be in the Olympics. Let me sign my name here. That's not how it works. What you have to do is you have to qualify. You have to try until people say, you know what, you're good enough to start doing the Olympics, so then you can come and compete in the Olympics. So that's what we're going to try and do here. So we need to write a function. Or we don't have to write a function, we have to write a program. And our program is basically going to be trying to ask the user whether they can qualify for the Olympics or not just yet. Okay? So we're going to start off by asking them, how high have you jumped so far? Right? Enter your high jump score. AKA, are you going to be able to compete at the Olympics? Qualify to ever go to the Olympics? We're going to see how high you've jumped before. Okay? So when we run that, enter your high jump score. Tyler, how high did you jump? How many meters?
Maybe like 1.5.
1 point, wow, very good. Okay, all right, so our system so far works. There's no exit, there's no error, nothing. Because right now we're just asking, right? We're asking, what is the high jump score? We print it out, qual height, okay? High jump score, you said 1.5, 1.5, great. Now we can use our while loop, okay? What we're going to try and do is, we're trying to see if you have qualified for the Olympics just yet or not. Tyler, a lot of pressure coming on you right now, okay? So, turns out, to qualify for the Olympics, you need a height of 2.17, okay? 2.17. So what we can say is, we're not going to let you qualify for the Olympics until you reach this threshold. So what we can do is start our while loop. Again, while is one of those key words that Python has. As soon as Python sees this word while, it says, okay, I'm going to make a while loop. So while the qualifying height, aka your high jump score so far, while it is 2.17, we want to keep on asking people whether they've qualified for the Olympics or not, right? Or actually, instead of equal to, we should probably make this greater than or less than. What should I put here? Actually, this will give you a clue about what we should put here. In this while loop, we're going to say, sorry, you didn't qualify for the Olympics. Try again. Okay. Then I'm going to want to update my qualifying height and say enter high jump score. Basically, in the system, what I want to do is I want to try over and over and over again with new scores until I qualify. All right? So we have our qualifying height. Let's assume it's 1.5, right? While our qualifying height, should it be less than or greater than? Basically, we want to come in here if we have not qualified yet.
Oh, less than.
Less than. While the qualifying height is less than 2.17, we have to go in here and say, sorry, you didn't make the cut, right? You did not make the cut. And then you have to ask them again. Go ahead and try again. What is your new high score? What is your new high score? And you don't stop until you reach 2.17 or higher. Okay? Then when we're asked, actually let's try that out right now. Enter your high jump score. Tyler jumped 1.5. Oof, tough luck. Sorry, you didn't qualify for the Olympics. Try again. Now how high did you jump?
Maybe 2.2.
Yo, that is a massive improvement. Congratulations. That's great stuff. Let's try that out. We finished. we ended our program. That means that we exited the while loop. Okay? We got out of there. Because, why is that? Because our qualifying height is now greater than 2.17. Okay? So if you get out of that while loop, what does that mean?
You qualify.
You have qualified for the Olympics. OMG. What the heck? What the heck? Wow. And then you're going to say, print, congrats. See you in, where's the next Olympics? LA. Oh snap, not so far away. Cool. See you in LA. So, let's run it. What's going to happen now? Let's enter a high jump score. Ella, how high did you jump?
2.6.
Oh, wow! 2.6! You qualified immediately. Ella's a prodigy. We all know this, right? This is great. You immediately qualified for the Olympics, right? So because your very first number was 2.6, right? Let's look at what happens here. We read here 2.6. We print out 2.6. We don't have to print it out anymore, so let's remove that for now. While qual height is less than 2.17, then we're going to do this. Qual height immediately is 2.6. Do we go inside this while loop at all? Yes or no? No, we do not go inside the while loop at all. And you can tell because we never said sorry you didn't qualify. They immediately qualified. Great job, Ella. Fantastic. Very high jumping. Okay? So think of this while loop sort of like its own conditional, right? You know how in conditionals when we had an if statement, right? If qual height is like, for example, equal to something, if it's equal to 3, then we would say print, you jumped 3 meters high, right? And we would never read this print unless the qual height was exactly, if this was true, right? That's very similar, That's very similar to this while loop. This while loop is kind of like an if statement, where if this is true, then you go in here, okay? Or while it's true, while this is true, you stay in here and you loop over and over and over again while that condition is still true, okay? So, now we have this. Fantastic. Okay. Yeah. So, what we can do is we can run this. Let's say Ismail's going to try this out. Ismail jumped 0.9. Bad start. Sorry, try again. 1.5. Caught it to Tyler. Still no. 1.6. Still no. 1.2. I messed up. I tripped, and that's not my fault, okay? But I did not make it. Next up, 2.0. Oof, getting there. Not yet. 2.1. Not yet. 2.12. No. 2.15. No. 2.17. I did it. I just qualified. Okay? How many times did I do this? A bunch, right? Ella immediately qualified. I did not. I took a couple tries, right? But this while loop means I'm going to keep on reading it over and over and over nonstop until that condition is no longer true. Does that make sense to everybody? Awesome. In this example, we also had a little if statement at the end, right? Where if your qualifying height broke the record, you can say not only did you qualify, but you broke the record. Okay? And this if statement is outside of the while loop, right? So as soon as you qualify for the Olympics, they just double check. If you're over 2.45, which is the current record, the longest standing record in the history of the sport, right? Then you could just print that out. Not only did you qualify, but you broke the record. Ella broke the record. Congratulations, Ella. Incredible jumping. Okay? All right. But with while loops, they're going to stay inside there until a certain condition is met, right? Or like until a certain condition is false. While something is true, it's going to stay in there. So that means that you never know when you're going to stop. What if you never stop? What if you're in an infinite loop? You will not stop at all. Okay? We can see that in action. This is what is called an infinite loop. This is infinite. Why is it infinite? While something is true, in this case, the Boolean true. What are Booleans again?
True or false.
True or false, right? While true, you're going to print out wake up, be awesome, and be kind. Okay? Let's try that out. We're going to move that over here. We're going to do this. We're going to run it. Oi. It does not stop at all until I click stop. I ended the program. I said, I've had enough. I can't do this anymore. So I stopped it. Okay? How many times did this print?
Infinite.
A ton, yeah. This is like, look at this little scrolly bar thing is hard to see for y'all. But look at all this. In those couple of seconds, we printed a ton of times. A ton. And it would have kept on going unless I stopped it. Okay? Why is this an infinite loop? Because in the other example that we had, we kept on updating and qualifying height, right? We kept on trying to update it and say, okay, try again. And then you enter a new number, and it reads that number. So the next time it checks to see, is that number greater than 2.17? And it keeps on checking over and over and over. Here, we have while true. Okay? You cannot update this true, and we cannot update that true because this is not a variable. Okay? That is not a variable whatsoever. That is a straight up Boolean. So this is while true, which means this will never stop. Ever. Okay? At all. Does that make sense? Okay? So that means you say print about to go into a loop now. Wish me luck. While true. And then you say print. Oh goodness. What a ride. Right? When are we going to read this line right here? Oh goodness, what a ride. When are we going to print that out?
Never.
Never. Ever. Ever. Because of this while true. Okay? What if I did this? Will we finally read this line?
Yes.
Yes. Why is that?
Because it won't read the while.
It's never going to read the while now. Are we ever going to read these three lines?
No.
No. Never. Okay? Just like those conditional statements, those ifs. If that if condition is not true, then you never go inside that if condition. If this was false, it never goes in here. And we can never update that false because this is not a variable that we update. This is like a straight up Boolean. So if we did that, like we said before, all this gets printed over and over and over again. We run that, stop it. We never made it. We never made it to, oh goodness, what a ride. Okay? So, just so you know, while loops can be infinite. Pretty wild. Okay? But some smart programmers thought, well, a while loop is very important, right? A while loop is very useful. So if you're doing this guessing game of guessing what a number that I have in my head, I will never stop until we find it. But what if you never find it, right? What if you have this while true? What if like it's been too long, right? We have a new keyword called break. Okay? Break. Break means no matter where you are inside the while loop, as soon as you see that break, you immediately get out there. You immediately leave the loop. All right? Let's look at what that looks like here. So right now, the way that it's written, without a break, will we ever read this line? No, at all. But with break, will we ever read this line now? Yes, now we can. Because this word right here, break, is another one of those key words for Python. Once Python sees this break, it's going to say, what loop am I in right now? I'm in this while loop. I'm going to get out of here immediately. So that means that when we read this code, let's run it. Now we only ever read everything once. Wake up, be awesome, be kind. And then we say, oh goodness, what a ride. Okay? Because it goes into here, the while true. It reads this, it reads this, it reads this, it read that, and immediately left and kept on reading the rest of the Python program. What if I were to put this here? What will be printed?
Maybe an error.
Maybe an error?
Or
Maybe. Let's try it out. Any other guesses? Yeah?
Maybe it'll like skip over the be kind.
Maybe it'll skip over the be kind, right? It'll never read it. Let's try that out. Let's run it. We say about to go into a loop now, wish me luck. We say wake up, be awesome, and yes, we skip the be kind, and we say, oh goodness, what a ride. So we don't get an error here because we never really wrote anything that would like mess up the system. All we wrote really was that as soon as you see this, just leave the while loop. It doesn't matter what happens afterwards, right? You can have a billion lines of code after this inside the while loop, but as soon as it sees that break, it's just going to leave. Okay, immediately, right away. So having a break just means you leave that while loop, and that's it. Does that make sense? Break is very similar to that return thing that we have for the function, right? Where once a function sees a return, it doesn't matter where you are in the system, you see return, you're out of there. Okay? Same thing with break. As soon as you see the break, you're out of there. Okay? So this break is going to be very useful whenever we have these infinite loops. Right? So, the ways to stop a while loop. One is that if your condition is false, right? So like when we were doing that high jump example, Ella immediately qualified for the Olympics, so we never even went into the while loop, right? So that would break the system, so you don't go into the loop at all. That's how you stop a while loop. The second one is the break statement that gets reached. So as we saw right now, we saw the break. As soon as it sees the break, you're out of there immediately. Okay? So that you do not at all read anything afterwards because you immediately left that while loop. The last thing that can happen is if there's a return statement inside of the while loop. So let's assume that you have this while loop inside of a function. Let's write it right now. Okay? So let's say you have this function right here, def my infinite loop. Right? We have all this together. But now let's return right here. Okay? If we were to run this, my infinite loop, what's going to get printed out?
up until be awesome.
Up until be awesome, right? It's going to print out wake up, it's going to print out be awesome, and then it's going to return and immediately leave the function, the entire function. How many times are we going to do this while loop? Once. Even though this is an infinite loop, the very first time we read it, wake up, be awesome, return. As soon as we see that return, it doesn't matter how many times we've done it, it doesn't matter if we're in the very first iteration or the billionth iteration. As soon as you see that return, you leave that function immediately. Just run it. Wake up. Be awesome. And that's it. Does that make sense? That's how you break a while loop. How much time do I have? I have 25 minutes. Okay, cool. All right. Here's an infinite loop. We start off with num being 0. While your number is greater than or equal to 0, you print out your number, and then you say, you are amazing the way you are. Okay? Beautiful. And then you have num plus 1. Oh, plus equals 1. So just as a quick note, plus equals for Python is the very same thing of doing this. Num is equal to num plus 1. Okay? Those two are the very same thing. You could either do num equals num plus 1, or you can do num plus equals 1. That's just a little neat fun fact for y'all. Okay? So, when we run this, we have read that 22,549 times until I clicked stop. And that took like what? A second? Maybe 2 seconds? And ran it that many times. Okay? Why is this an infinite loop?
This never goes, because that statement is never false.
This statement is never false. We start off at 0, num is greater than or equal to 0, and we keep on adding 1, right? Just keep on adding and adding and adding 1. What if we want to print this whole thing out like 100 times? What can we do? An if statement, we could do it that way. Where should we add it? After the num? Yeah. If
num is equal to 100.
If num is equal to 100, return. Let's run that. Oh. We said return, but return is only if we're inside of a function. We're not writing a function here. That's okay. So what word can we use instead of return? Break. Boom. Okay. We run that. We get all the way up to 99, which is totally fine because we start off at 0. And we did it 100 times. Fantastic. That's one way to do it. You can do it another way too. Instead of having this if num is equal to 100, then break, what you could also do is, while your number is, let's say if it's not equal to 100. Okay? If your number is never equal to 100, you're going to stop the while loop. You're going to say print ended loop. Okay? You can also do this, where now you're going to keep on adding num plus equals 1. It keeps on incrementing up by 1. And then it keeps on checking this while loop, right? So when it gets here, it loops back up. It checks to see, is num equal to 100, yes or no? If it's not equal to 100, you go inside. If it is equal to 100, right? 100 is not equal to, or if 100 is equal to 100, then you leave. You immediately leave the while loop. Does that make sense? Yes, no, yes, no? Okay. Cool. So those are infinite loops. Why do we have infinite loops? Well, you can use these infinite loops to try and interact with the user until like a desired thing is reached, right? You keep on asking them stuff over and over and over and over and over and over and over again until something is reached. So here we have a code example. We have a list of Central American countries: Belize, Costa Rica, El Salvador, Guatemala, Honduras, Nicaragua, and Panama. These are all countries in Central America. Okay? Then you go into your while loop. While true. This is in what kind of loop? Infinite. This is an infinite while loop, right? So then you check to see, please enter a country, right? You enter a country. If that country is in Central America, which is a list, it just goes and checks to see whether what you inputted is in that list. If it is, you have correctly chosen a country in Central America. Then you can break out. Okay? Otherwise, you say you didn't enter a Central American country. Try again. Okay? So now if we run this here, run that. Shout out a country, any country at all. USA. That is not a Central American country. Try again.
Mexico.
Mexico. That is not in Central America. Let's try again. Give you a little hint right there. Which one, sorry?
Costa Rica.
Costa Rica. Oh, that's not there. Why is it not there?
What was the capital of the Argentine capital?
Yes. We have to make sure it's exactly the same. Costa Rica with the capital R. You have correctly chosen a country in Central America. Done. So having these infinite loops help us out so we can keep on interacting with the user over and over and over again. Okay? And then we decide when we leave with this break. Okay? Does that make sense so far? Yeah? All right. Okay. Shifting gears just a little bit. We're now going to be doing something called importing modules. Okay? Importing modules. What does that mean? A module is basically like 1,000 or 1,000,000 lines of code that someone else wrote. And we're going to say, we want to import that into our system. Basically, 1,000, 1,000,000 lines of code that someone else wrote. I'm going to say, I want that. I want that here in my file right now. And I want to use that, whatever it may be. And we can do that using this name, import. Okay? And there's a bunch of modules that Python has. A ton. We can create our own modules if we wanted to. Right? But there's some certain modules that are super duper important and very highly used. Okay? And one that we would be using in our classroom for the rest of this course. One of which is random. Okay? Random. Here's just a couple things that it looks like, right? So when we import a module, we have to actually say import that thing. Import is another one of those keywords. So as soon as Python sees that, it says, I'm about to bring in like 1,000 or 1,000,000 lines of code. Or it could be like one line of code. I don't know. But I'm going to bring something else in. I'm going to import it. I'm going to bring it in. Okay? Import. Let's import math for now. Okay? When we do that, we run it. All good. No errors. Okay? What we can do now is we can use math. Math has a ton of functions inside it. A ton. And we want to access those. Okay? So what we can do is we do math dot. Okay? When you immediately do that dot, you're going to get a lot of these. You can do a cosine, okay, sine, tangent, sine, there's a bunch of stuff that you can use math with, right? A bunch of stuff. For now, let's just use math with math.py, okay? If you were to do math.py, it doesn't just hold functions, it can also hold information, right? So what's the value of pi?
3.14.
3.14, right? And pi can be like, I think it's like an infinite number of decimal places. I think it's like 3.1415926. I don't know. I'm going to say 3.1415926. Let's see if I got it right. This is just a little extra thing. 3.14159. Oh, yes. I didn't know anything after that, right? But basically, this thousands or millions of lines of code also has like a variable basically called pi. And we're accessing that variable pi. Okay? What I'm trying to show you with this is that we can import a bunch of other things, right? Math also has this thing called power, right? And this is the power. So 2 to the power of 2 would be 4. 2 to the power of 4 is 2 times 2 is 4, times 2 is 8, times 2 is 16. Run that, 16. This is very similar to this, right? 2, 4. Very similar. It's just that someone else wrote this with like floats or something, right? And math dot factorial. Do we know what factorials are?
Like, say 5 times 4 times 3.
Yes, yes. So print math dot factorial. So factorial is basically, factorial is basically given a number, make it that number times one number less, times one number less, times one number less, up until you get to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 100 factorial is 100 times 99 times 98 times 97 times 96, up until you get to 1, right? So we run that. Factorial of 5 is 120. Okay? The reason why we have this, why I'm showing you this, is because basically someone else wrote that stuff, and I don't have to worry about it at all anymore. Okay? We could write our own factorial thing, but why should we write something that someone else already wrote for us? Right? Something that has been tried and true and tested. So we can just use math.factorial. Let's use something else called random. Okay? Also, just as a quick aside, if I say import random and then I say math.factorial, remember, if we never imported math, the system is going to get mad at us. Because it's saying, you're saying you want to use math.factorial? I don't know what math is, right? Unless you import it. Okay? So we're going to import something called random now. Import random. And we really like to use random because random will give us something random. Okay? Rand int, rand int asks for 2 different things. And it'll give you a random number. Okay? So if we did random 0 to 5, it's going to give us a random number between 0 and 5 every time we run it. Okay? As you can see, anytime I run the system, I get new numbers. Here's a 0. Let me run it again. That's a 3. Let me run it again. That's a 5. Let me run it again. That's a 4. Okay? Random is going to give us something totally random. Okay? This is very important for y'all to know. Random will give us something random. I know it sounds very redundant, right? But random is going to be something that we can use a ton, okay? To make games. Let's make a game right now, actually. Let me see. We have 12 minutes left. Let's see if that's the next thing. Yeah, our guessing game. Okay? So, remember before when I said I'm thinking of a number between 1 and 10, right? And then y'all had to guess what that number was? We can do that game right now. Okay? So, before I write anything, how did that game work? What's the very first thing that happened when I said let's play a game? Okay? And I'm going to think of a number between 1 and 10. What's the first thing that happens when that game starts?
You think of it.
Yes, I have to think of a number between 1 and 10. Okay? A random number. At one point it was 7, and at another point it was 2. Right? So the very first thing we want to do in this program is think of a random number. How do we create a random number?
Rand int.
Rand int. And let's say we want a number between 1 and 10. Okay? I think rand int is also inclusive between both sides. So between 1 and 10, 1 is also included and 10 is also included. Okay? Rand int. Okay? What's going to happen when we run this code?
Nothing right now.
Nothing right now, right? Do we save that number anywhere? No. Let's save that number. My random number. Okay? Go over my random number. Now, what's the next point of the game? The next thing in that game, what do I do?
Asking people.
Ask, right? I have to ask. What is the number that I'm thinking of? Okay? So, right now, let's ask. What is the number? What's going to happen here?
You ask the user.
I ask the user what is the number. I say what is the number. Then I can say like 7. And nothing happens. Because we don't do anything with it yet. Seems fair, right? Okay. Are we saving that number anywhere? No? Let's save it. My guess. Okay. Right. That worked well? So now we have my random number and I have my guess. Right? If you got it right, if my random number is equal to my guess, you say, congratulations. You got the right number. Okay? But what if they didn't get the number right? What happens? I'm thinking of a number between 1 and 10 right now. What is it?
5.
5. No.
3.
What did I just do right there?
Ask again.
I asked again, right? What's the number? What's the number? Until I get the number that I'm looking for. That number was 6, by the way. But, you know, whatever. So, I want to keep on asking until I get the number that I'm looking for, right? So, what does that mean I should do? If I need to do something over and over and over again until something happens,
Well,
a while loop, right? So I got a while loop. Let's put it right here. While my random number is equal to my guess,
not equal.
not equal. While the number is not equal to my guess, I'm going to keep on asking. So I'll put input, what is the number? Right? Is this going to work?
No.
You need to update my guess.
I need to update my guess. What were to have happened if I didn't update my guess?
It would keep going.
For how long? Let's say we didn't have it like this. Let's say my number is 6, right? First thing I ask, what's the number? Someone says 3. Is 3 equal to 6? No. We go in here. And then I ask again, what is the number? Someone says 6. In theory, they're supposed to get the number right. Right? But we never saved this question. Because we never saved that question, it's like me saying, what's the number? You say 6. But it went in through one ear and out the other. I don't even know what you said, right? I don't remember what you said. So I could never check to see what that number was. So how many times would I be doing this while loop? Infinite. Because my guess never changes, right? My guess never changes, we never leave. So my guess. Now we can update the number. Or we can update the guess. So now, is this going to work? Now we're asking for a guess of a number. We have my random number. While the number is not equal to my guess, if it's not equal to the guess, I could say, I could also print out, whoops, wrong number. Okay? Then I keep on asking, what is the number, what is the number, what is the number? Waiting for you to get the right number. Okay?
Wouldn't it be better if the if statement was in the while loop?
If the if statement was in the while loop, this one right here?
Yeah.
Yeah, we could do that. Okay. We could do it like this, right? Now this if statement is inside the while loop. We could do it that way. But if we do it this way, what should we do too? Yeah,
Break.
you would have to break out.
Oh.
Because if you had this if statement inside without a break, even if you get the right number, it's just going to keep on going. It's going to keep on looping, right? So for now, let's just leave it outside,
Oh.
right? Just for now, let's leave it outside. Or also, actually, thinking about the logic of the game. How much time do I have? Oh, I have 5 minutes left. Okay. Thinking about the logic of the game, we could have this if statement inside. However, if we have this if statement outside the while loop, what would that mean? So like we could have this if statement inside, we could have a break right here, right? And we could like leave the while loop. However, we can also leave it like this, because what it says here is that we will never read this line. We will never read these lines at all unless we get out of the while loop at some point, right? When are we going to leave the while loop?
When my random number is not equal to this.
Or when it is equal to it, right? So when it's not equal to it in the while loop, it'll stay in here while they're not the same. But as soon as they are the same, we leave the while loop, which means that every line after this, we know that my random number will be equal to my guess. So, in fact, we don't even need this one right here. Okay? Whoops. We can have it like this, right? And we can say, we're going to keep on asking for numbers until we get outside of the while loop. And as soon as you get out of the while loop, then you know, by the time I read this line, my random number should be equal to my guess. Right? Let's try that out. Let's run it. This is a random number. Let's try out some numbers.
10.
10. It's not that one.
3,
3. Not that one.
4,
4. Nope.
2.
2. Nope.
8,
8. Nope.
1.
1. Nope. What have we tried so far? We tried 1, 2, 3, 4, 8, and 10. Let's try 5. Nope.
7,
7. Nope.
6.
6. Nope.
9.
9. No. We tried all the numbers. What's going on here?
It isn't updating the value.
The value is getting updated. My guess is getting updated. We're never updating my random number, so the number should have stayed the same the entire time. Why is this not working? Yes?
The input's a string.
The input is a string. The input that we get from the user is always string. Always. How can we change the string into an integer?
It would be int input. What is the number?
Yes. Int input. What is the number? We should do it here as well, right? So now anytime we read in a guess, now it's going to be a number. Finally. Okay? Let's run that now. What's the number? Let's shout out a number.
7,
7. Nope.
1.
1. Nope.
2.
2. Nope. Tyler, what do you think?
5.
5. Nope. Ella, what do you think?
9.
9. Nope.
8.
8. Nope.
10,
Caesar, 10. Aye! We did it! Okay? We found the number. Congratulations! You got the right number. Okay? Fantastic. So now, we just created a game. Okay? On Python with some very simple code. We had a total of 11 lines of code here, and we created a game. And you could show it to your friends and family and say, check this game out that I created. Okay? Write this at home. We have 1 minute left. But we can also make this game even more interactive. And I'll do it really quickly so you can see what I mean. What you can do to make this game more interactive is instead of just saying, oh, you got the wrong number, we can also tell the user whether the number is too high or too low. So I'm thinking of a number right now, between 1 and 10. What is it?
5.
Oh, you got it. Let's think of a number. Between 1 and 10. Go.
4.
Higher.
6.
Lower.
5.
5. It was again. 5. Right. So what we can do is we can tell the user to make it quicker for them to try and get the right number. So if my guess is greater than my random number, what we can do is we can print. What are we going to print out? Go higher or lower? If my guess is greater than my random number, what should it be?
Go lower.
Go lower. Okay. We can do else if my guess is greater than my random number. What can we print?
Go.
Go higher. Okay. So now we're going to run that. What's the number? Shout out a number.
7.
7. Go lower.
5.
5. Go lower. Tyler.
2.
2. Go lower. Ella.
1.
1. Hey, we did it. Fantastic. Right? So now this game gives more feedback. Right? So it's instead of just like random guesses from us, now we can make more strategic guesses. Right? So if we see 5 and it says go lower, we're not going to say 6. We can start going lower. And now you can make this from 1 to 100. And it makes it a lot easier now. So between 1 and 100, let's start with 50. Go higher. Oof. Higher. Between 50 and let's do a 75. Go lower.